Okay. Sorry. So for today, I will continue our discussion with the next topic. Is about the frame and machine. Okay. And for you guys who still have any question about the fast or all the topics from the beginning until fast for tomorrow's exam. Okay, I will open the Q&A session for just for the exam tomorrow in the last 1 hour, last 1 hour of the class. So from 8 in the morning until 9 in the morning, our discussion will be focused on the exam tomorrow. Okay, but for today, I will continue with the discussion for the frame and the machine. And I believe as well, last week I gave you guys homework, okay? And part of those homework actually already discussed about the frame, right? Number 4 and number 5, if I'm not mistaken. So basically, what is frame and what is machine? Okay, a structure, we call it a structure as a frame or machine. If at least, okay, remember this one. If at least one of its individual members is a multi-force member. Okay, remember, in the trust system, okay, in the trust system, all the members in the trust is all the members we consider is supposed to be a two-force member. All the members are two-force member. Okay, there are no multi-force member in trust system. But for machine or frame, okay, we have at least one multi-force member. That's the main difference between frame and machine and the truss. Okay, so for truss, all members are two-force member. Okay, all members are two-force member. But for frame and machine, okay, at least one of each member is considered as multi-force member. Multi-force here is more than two-force member. So the number of force working on that particular member is more than 2. Okay, for this particular definition, is it clear enough? Because this is the most important definition that you're supposed to know for to differentiate between frame and machine and trust. Any questions?
So, sir, can you elaborate on multi-force member?
Multi-force member is something like this. Okay. Previously, when we talk about when we talk about the framework, for example, if we have a bridge like this, okay, okay, all the member here is either under tension or compression. When I talk about multi-force, two-force member in the previous in truss, okay, when we take a look at the individual members, it's either like this, under tension or under compression, right? We call this kind of member as two-force member. Why we call it as two-force member? Because the forces which is happening at the particular member only happening at both ends, and the number of forces working there at one member is only 2, not more than 2, only 2. Okay, at both ends. That's all. So that's the definition of thrust. So the forces happening at each member, at all the members, are only happening at both ends, and it's either tension or compression like that. But when we talk about frame or machine, there is a possibility that we have a member like this. This is another example of the members, okay, which has a force like this. Okay, same as here. And then we have external force like this, or plus additional moment like this. We consider this as a multi-force member. So as a multi-force member is a kind of member which is non-two-force member. Do you get it, Hasan? When we talk about two-force member,
so it doesn't
something
only
like
so it doesn't only work on the ends, not unlike a truss.
Yep, correct. So basically, for two-force member, it's always like this. Only the force is only happening at both ends and either and the compression or tension. That's simple. We call that as two-force member. If it's considered as non-two-force member, then it must be multi-force member. You get it, Hasan?
Oh, I see now. Okay.
Yeah, something like this, or even it's just like this, right? We consider that as a non-two-force member as well. For example, if we have the same bridge like this one, okay, the same bridge as this one. Okay, same bridge as that one. But the problem now becomes slightly different because we have a force here, additional force here, and we have additional force here, for example, and the force happening at the middle of the member. So for this particular case, right, this particular member is not two force member anymore, and this particular member is not two force member anymore because the force which is happening at those two members are not just happening at both ends and are not just under tension or compression. So if we draw the free body diagram of both non-two force member there, it will be like this. Because it's non-two force member anymore, so we have to draw the forces which is happening there completely, like complete in the complete form like this. And this one is the external force. So the number of forces which is happening there is not two anymore. It's more than two. Do you get it, Asad?
Also, if a truss is given like a mass, like above it.
Yes, correct.
Also,
we cannot consider it as a two force member anymore. When the mass, we have to consider that as when we have to consider the mass, okay, of a truss system, then we cannot consider it as a force member anymore because like it or not, we have to put the force in the middle of the member. Like I said, yes, you are correct.
Also, it is possible after all to turn truss to make truss not a two force member.
Yes, it is possible.
Oh,
in the real world, when you talk about structural things in civil engineering, but sometimes if the member is too heavy and we cannot neglect the mass of the member, okay, if you cannot neglect the mass of the member, then you have to analyze it as a non-two force member. But most of the time, okay, the for the truss, most of the time we can neglect the mass most of the time because the external forces which is happening at the frame in comparison to its own weight, right? Its own weight is normally the external forces is much bigger. So we can neglect the weight. Like that. You get it, Asa?
Oh yes, I get now, sir.
That's why for your case, right? If the weight is not known, then your assumption must be the weight is negligible. That's the easiest assumption. Because the analysis will be much easier if you can neglect the weight like that. Okay, supposed to be clear enough, right? What's the difference between the purpose of this particular slide is whether you can differentiate between two force member and multi-force member. Okay, and when we have a trust like this, when we have a trust like this, and we have for example, if we have something like this, a problem like this, we cannot consider this problem as trust anymore. Why? Because we have more than at least one member that is non-two force member or multi-force member. So the requirement for trust system is all the member must be two force member. Something like this. Okay. Once only one of the member become non-two force member or multi-force member, okay, that particular system, that particular structure, we cannot consider it as trust anymore. It becomes frame or machine. Okay. Any question about it? About the definition? That's the most important thing that you're supposed to know.
So,
Definition first, yes. Yes, Azhar, yes.
So if there is one multi-force member, can we say that it's a frame or machine directly?
Yes, must be.
Okay.
Yeah, must be either a frame or machine. Frame or machine is a definition of structure where at least one of the member is multi-force member. So it must be either frame or machine. How to differentiate between frame and machine? It depends on the device. Okay.
Okay, sir.
Okay. Any other question about this? If not, I will continue with the next one. Okay. Just now, we talk about how to differentiate between frame and machine and truss. Now, I want to differentiate between frame and machine. How to differentiate between these two? Okay. The definition is actually quite clear there. Okay. Frames are structures which are designed to support applied loads and are usually fixed in position. Okay, this is the definition of the frame. Yeah, why I put it like this, of frames. Okay, structures which are designed to support applied loads and usually fixed in position. Okay, structures which are designed to support applied loads and are usually fixed in position. Okay, for example, it's like this. Okay, and machine, on the other hand, are structures which contain moving parts and are designed to transmit input force or couples to output force or couples. So normally, when we talk about a machine, it must have normally it has some kind of mechanism. For example, it's like this. We call this as a machine because normally we use it to transmit force from here, the force which is given by our hand, to here, to process the material there, something like that. Or something like this, we consider it as a machine as well. This one. We consider it as a machine as well. Okay, this one we consider it as a machine as well, to transmit force, to transmit input force to output force couples. Like that. Okay. Frame normally is just to support applied loads at a fixed position, something like this. Okay. This kind of definition is actually for sure in the exam we will ask. I will ask you, or the other lecturer will ask you. Oh, this is, can you differentiate between this and this? Is this a frame or machine? No, we will not ask you for that. But in the final defense, your final defense, sometimes some lecturer may ask for it. Are you consider this as frame? Are you consider this as a machine? Like that. Okay, but the definition is not that hard. When we use the device to transmit force, transmit the input force, and change it into another force to process something like this, we call it as machine. But if it's just to hold the to support the loads, to support the applied loads like this, we call it as free. Okay, I believe it's supposed to be clear enough, right? The difference between machine and frame, okay, and the difference between both frame and machine and the truss. So I believe the definition that I believe right now you can differentiate between those three. Oh, can you consider this as a truss? Or we supposed to consider this as a frame or machine? Okay, so I believe you already understand about that. Okay, this is the analysis procedure made by Pak Ferry, but actually you don't have to follow this. Okay, as long as you try to keep practicing, okay, you will know how to handle a problem using this sequence, but automatically, because I believe that you cannot forcefully follow this particular sequence without keep practicing. Okay, so uh, the procedure for us to analyze this frame or machine is correct. It's actually supposed to be like this. When we have a frame or machine, the first thing that we're supposed to do is to try to analyze whether it has a two force member or not. Okay, if it has two force member, then isolate those two force member, and then draw the free body diagram. And then the two force member, normally we can isolate it as an external force, replace it with an external force when we draw the free body diagram. Then after that, we can calculate the number of unknown, then calculate the number of equation. If it's the number of unknown and the number of equation are equal, then we can proceed by applying the equilibrium equation to solve the problem. Like that. Okay, that's the sequence. But I'm a believer of not following this exactly. Why? Because if you just keep following this and without practicing at all, it will be just useless. So for me, it is better for you to keep practicing, because later after you keep practicing, you can do this process automatically, and that's the most important thing. Because statics is kind of a subject where practice makes perfect. You can perfect yourself. You can perfect the way you handle things by keep practicing, because it's just following the procedure. Okay, you don't have to how to say it? You don't have to memorize this. Okay, but at least if you want to know the correct procedure, you can just take a look at this. Okay, actually that's all the theory behind it, and the rest will be problem example. Okay, I think I will start with the previous homework that we have. Okay, I will start with the previous homework that we have. I give it to you. Found homework. This one. Yeah. We share screen. No. Okay. Okay, I believe this is the previous homework that I gave it to you. Right? The deadline. Okay, yes, of course, you can go to the level 3. Okay, and I believe the deadline is today. Right? Correct.
Already past the deadline, Pak. 10 o'clock.
Yeah. So, number 1, number 2, and number 3 is actually the problem where I keep giving the trust problem, because the exam is only until trust. The midterm, the first midterm exam is from the beginning. From the topic will be from the beginning of the semester until trust. So this is for you to keep practicing, and I believe the problem is not hard enough, and it's not hard enough. I believe it's still solvable. This one maybe the problem is with the geometry, and this one is the previous exam problem. So you can practice with this. Okay, this is the previous exam problem. So the level of the exam will be like this, quite close to this. And one more thing, okay, because tomorrow at night will be the exam. Please never think about cheating. Okay, never think about cheating. Okay, we will be able to catch you guys from just looking at the answer. Okay, we are experienced enough on that. And actually, we did catch a lot of students from your seniors, 1-year seniors, okay, in the previous mechanics materials exam. And a lot of them got the surat pendamping ijazah ya. Okay, so in their surat pendamping ijazah, okay, it will be written there that they have cheated before. It means that you will be judged as a cheaters the whole life. So never think about cheating in tomorrow exam and in all of the exam. Okay, is it clear enough, guys? I believe it's supposed to be clear enough, right? And this is the frame problem that I give you guys last week as the homework, where the deadline is the 10 a.m. 2 days, and this one as well. Okay, I will start with this because this is maybe one of the simplest problem. Okay. Any of you can solve for this problem or this problem? That's risky.
Sorry, sir.
Can you solve this? Risky?
I think so.
Okay, good. How about this one?
This one as well I can.
Okay, good. It's supposed to be straightforward for this one. Fasa Diara, can you solve for this one? Fasa?
Yes, I answer for this one.
Sorry?
Yes.
Okay, good. is supposed to be good. Any of you having a problem with number 4 or number 5? If no one having a problem, then I will not discuss about this. For this number 4, both of the member are non-multi-force member. So AB is a multi-force member, BC is multi-force member. And for number 5, the same. Okay, BC is non-multi-force member, multi-force member. BC is multi-force member. AO is multi-force member, but CD is two-force member. CD is a two-force member. Okay, CD is two-force member. And the one in question here is the node assembly is raised because both problem is quite similar. Then I will just continue. I will just do number 5 because it's slightly more complicated. If you can solve for number 5, number 4, it will not be any problem for you. Then I will discuss for this. Okay, the node assembly is raised by the application of torque M, yeah, to the link BC through the shaft at B. Okay, if the arm and wheel AO have a combined weight of 100 lbf with the center of gravity at G here. So here there will be a weight, right? Downwards 100 lbf. Okay, 100 lbf downwards. Then the one in question is find the value of M necessary to lift the wheel when D is directly under B. Yeah, D is directly under B. So in this particular position, you must try to find the value of M necessary to be given there, to at least be given there to lift the wheel. The weight is just from link AO and the wheel there, 100 lbf there. That's all. That's all the weight. Okay. Then how can you solve that? How can you solve it? Okay, that's the question. How can you solve it? Let me check with. Pasha, can you help me with this one?
Saya juga sebetulnya agak kurang ngerti sih Pak, nomor 5.
Ngerti, kenapa tadi ditanya nggak jawab? Tadi cita
Ragu tadi Pak.
Ragu, agak kurang ngerti di mana?
Sebetulnya tentang frame itu saya masih belum terlalu paham sih, tentang apa namanya cara pengerjaannya dan sebagainya, itu masih belum begitu mengerti.
Biar kamu bisa mengerti, tolong bantu saya mengerjakan ini. Nanti saya coba bantu guide, ya.
Oke, Pak.
So for this one, remember just now I told you guys using Pak Feli's flowchart, right? The first thing that you're supposed to do before you analyzing a frame or machine is to try to find out the two force member. Can you find out the two force member, Tasha?
CD Pak.
CD, yes, because I give it to you already, right?
Yeah.
CD is two force member, but you know, right? Why CD is two force member?
Because it only has two force.
Yep, because the force is only given by the other member at C and at D. Correct, right?
Yeah.
So must be, in that case, it must be a two force member. Then CD is a two force member. Then after that, we have to, we can try to isolate two force member and replace it with external force. So the first thing that we're supposed to do is to try to replace CD with external force and divide the system into two. Why we have to divide the system into two? Because if we try to combine, when we talk about frame, it will not be possible for us. Sometimes it will be possible, but most of the time it will be very hard for us to solve the system without dividing it into several free body diagrams. For this case, we have how many multi-force members, Pasha?
BC,
BC and AO.
AO, yeah.
So we have two multi-force members. Normally, for frame and machine, normally most of the problem, we can solve the problem by dividing the system into the number of its multi-force member. So in this case, we have two multi-force member. That's why in this case as well, we can solve it by dividing the system. Okay, by dividing the system into two for each. So one for each multi-force member. So if I want to draw the first free body diagram, then I can do it this way. BC, right? BC, okay, BC, I can draw BC like this. Okay. Then at E, there is a pin, right? So there is must be what? When we have a pin, there must be what?
Force ke atas, Pak.
Yeah, not just going up, but going up and going right as well.
X and Y direction, Pak.
Yeah, correct. So we have dy and
Dx.
dx. And beside that, we have moment there. Right?
Yeah.
This one, moment. Counterclockwise moment. Okay. And what else? At C? What force do we have at C?
CG.
C?
CD,
FCD, correct. Because CD is a two force member. So the force which is given by CD, by member CD to point C at member PC, it must follow the direction of CD, correct, right, Asa?
Yeah.
So this is the line of action of Aya. This is the line of action of force CD. Okay. Now I'm asking you, do you want to assume it as a tension or compression?
Tension.
Tension. If it's tension, then at C, okay, the direction is supposed to be going down or going up?
Going down.
Going down, correct, Asa. So this one is FCD. So this is the first free body diagram for member BC. Now the second free body diagram, we have to draw it as well for the member AO. Okay, if we have then the system is like this. Yeah, just roughly like this. Okay. Then I will try to draw the at G here. There will be a force downwards 100 lbf, right?
Yeah.
Okay. And then what else do we have here?
AY and AX.
AY, AX, correct. AY, AX, and what else?
DC, Pak.
DC, yeah. So tension, right?
Yeah, tension.
CD. So at point, yeah, at point D here, the line of action is supposed to be like this. It's supposed to be going up or going down?
Going up.
Going up because it's tension.
Because it's tension.
Right? Yeah. FC. Is the problem complete? Pasha?
No, Pak.
What else that you have?
Can you repeat that?
No, I mean
Question?
the free body diagram, both free body diagram are complete.
Complete, Pak.
Not yet. You have to complete it with all the dimension actually. Yeah, actually you're supposed to continue with the dimension here. The theta here is supposed to be 30 degrees, right?
30 degrees.
Yeah, because of this, theta is 30 degrees. So here the theta, yeah. Here the theta is 30 degrees as well. So all the distance there, we have a distance there as well. 16, 20, or 20 inch. Both of this and this are 20 inches, and the theta here is theta there is 30 degrees, so here must be 30 degrees as well. Okay. So here is 30 degrees as well. Okay. The length here, when we talk about the length here is
20 inch.
20 inches. Yeah. Y and sides. Okay. Now for the bottom one, the angle there. Okay. We have a 16 inches and 32 inches, right? Can you help me? What is the angle here?
Is wait. 30
It's alpha. So tangent alpha there must be what?
Tangent alpha is
not tangent. Sorry, it's not tangent. Sin alpha. That's the easiest way. Sin alpha must be 16 inches divided by 32 inches, right?
Yeah, depan per miring.
0.5, right? Okay, sin alpha is 0.5. Then alpha is what?
Wait. 30 degrees.
30 degrees. 1, 2. Okay, yeah, right. 1, yes, 30 degrees. Alpha must be 30 degrees. That's all. Then we have the length here. We have several lengths there. Okay. This one is 32 inches. And this one is 8 inches. Okay, I think it's supposed to be complete, right? No?
Yeah, Pak.
Now, in order to solve for this, right? How can we solve for this, Pasha? What's the thing that we need to solve for M? The one that is in question is M. In the first free body diagram, in order for us to solve for M, what value that we have to know?
M-nya dibagi jadi ini nggak sih, Pak? Jadi apa namanya? Dua force dengan jarak tertentu itu.
Enggak usah. Kita selesaiin aja langsung di sini. Coba. Okay, let me ask you, Pasha, how many unknowns that we have at the first free body diagram?
3, Pak.
Not 3.
Oh, 4 sama M.
Yep.
Yeah.
We have 4, right? 4 unknowns. Can we solve for that?
Using
How many
sigma
equations
fy,
that we
sigma
have?
fx.
Sigma
4.
fx equal to 0. Sigma
Oh,
fx1 equal to 0. Sigma fy. Sigma fy1 equal to 0. And sigma moment 1 equal to 0. So many equation.
3 equation.
Only 3 equations. How many unknowns?
4.
Can we solve it? Can we
No.
solve it directly? No. Now, take a look at the second free body diagram. How many equations there? Sorry, how many unknowns there?
3 unknowns. AY, AX, and FCD.
Okay, 3 unknowns. Can we solve that?
Yes.
Yes, we can. Then, in that case, we have to solve for this first, right?
Yeah.
Because we can solve it using sigma fx2 equal to 0, sigma fy2 equal to 0, and sigma moment 2 equals 0. Okay, we can solve for ax, ay, fcd, right?
Yeah.
Okay, but there the question is, we have to find only m, right? The moment m. Ay and ax is not us there, are not us there, right? Okay, if I try to use sigma moment 2 at point A, okay, I will be able to directly find FCD. Correct or not? Sigma moment sigma moment at point sigma moment at point A equal to 0. By doing so, I will be able to find FCD. Correct or not?
Correct, Pak.
Do you understand, Pasha?
Yes, Pak.
Okay, we will be able to find FCD by sigma moment at point A. Then use the value of FCD in the first free body diagram to solve for M. Once again, we can use sigma moment at point B equal to 0. We will be able to find M directly there because dx and dy will be eliminated using that particular sigma moment. So 2 equations is enough to solve for this. Do you get it, Pasha?
The equation is sigma moment and
Sigma moment A equal to 0 using the second free body diagram, and sigma moment at B equal to 0 using the first free body diagram.
yeah.
You get it?
I understand, sir. I get it.
Anyone else here? Can you catch my explanation?
Sir, for the
Yes,
sigma
Aaron.
moment
Yep.
B, how I'm a bit confused on how to calculate the M.
How to calculate the M using the first free body diagram when we already find FCD from the second free body diagram, you mean? That's the question. Hello?
Right now, I guess how to put it here, to do the equation at the sigma moment at B. I'm a bit confused.
Oh, that's your question. Okay. For the case sigma moment at B, then sigma moment at point B equal to 0, right? So we have to calculate all the moment which is happening at point B. Okay, in that case, right, we have to calculate for now I'm asking you, Px there will it cause moment at point B or
No.
no? Because the distance, perpendicular distance is 0, right? The same for By. By will not give any effect there because the perpendicular distance is 0 as well, correct? Right?
Yes.
Yeah, okay. So now the effect will be just between FCD and M. So using sigma moment at point B equal to 0, then what we have, if we want to use a clockwise moment as positive value, then FCD, okay, FCD sin 30 degrees multiplied by the moment arm. The moment arm is 20 inches, right? Okay, minus M equal to 0.
You just put the M immediately without times it by the distance.
No. You don't have to multiply M with the
already
perpendicular distance, because M is already a moment, right?
Oh, I see. Oh, I'm just a bit confused about that.
Yeah. M is a moment. If it's a moment, then you have to put it there. It will be only come up in the sigma moment. It will not be there in the sigma fx and sigma fy. It will only come up in the sigma moment, but you don't have to calculate. You don't have to multiply it with the perpendicular distance anymore. Okay.
Yes. I want to ask also about the alpha, the 0.5. I'm a bit confused. Well,
Okay, this one, why is 0.5? So
yes.
here, alpha, I define it as this angle. This angle is alpha. Can you get it?
Yes, I understand.
Okay. For this one, sin alpha, right? Sin alpha, it must be this distance, right?
Yes.
Divided by this particular distance, right? Right.
Yeah. Yes.
So from AD, so the horizontal distance from A and B divided by the distance between A and D. Right? The horizontal distance is there, yeah. 16.
You study for the A and D.
Yeah, that's A and B, right? That's the horizontal distance between A and B, right? So sin alpha here must be 16 inches divided by the distance between AD. AD there is 32 inches. 0.5, right?
Yes.
Izin bertanya Pak, untuk
So, wait a minute. Aaron, can you get it?
Yes.
Okay.
I understand. Thank you.
Okay, good. Ya, pasal.
Untuk kan alfanya di situ ya Pak. Kalau sin itu kan depan per miring, berarti kan 16 inch per AD. Cuman kan yang diketahui di sini itu 32 inch itu
AD kan itu?
Oh iya. Sorry Pak.
Nah,
Salah lihat
itu
Pak.
AD. Ini
Iya.
AD. Ini yang horizontal.
Salah lihat ya. Terima kasih Pak.
Okay. Any more question? Any more question? Rizky, do you understand, Rizky?
Yes, I do, Pak.
Did you do it correctly or not for your homework?
I think so, Pak.
Okay, good. I think
I want to ask. So the alpha in here, you get it from the the sides, right? Yeah, not from the
this one. This and this.
Yes, not from the theta 30 known, right? Yeah.
Nope.
Okay.
Okay. I think stop sharing. Discard then that I will go to structure. This one, then share again. This is not a simple problem, which maybe actually you can start with as well. Okay. Now I think I will ask. Ooh, here I will ask. Okay. S3. Can you help me with this one, S3? Hello, S3. Hello, S3. Where are you, S3? Oh yeah. Anyway, guys, don't forget to mark your attendance. Okay. I already opened it from before we start the class. S3 is not around. Where is S3? Yes, sir. Oh, you have a problem with your mic? Okay, then that is no worries then. Then Adila, in that case. Adila, can you help me with this? Adila?
Yes, I think.
Okay. The first thing that you must try to help me is, can you find the first member in this particular problem?
AB.
AB is the first member. Yes, you are correct. AB is the first member. How about EC? This is the first member or not?
Not.
Nope, this is not first member. Correct. And from the previous flowchart, we can try to replace AB, isolate AB, and replace it with external force, right? Okay.
Right.
Now, please help me to draw the free body diagram of member PC.
So there's CX and CY at point
CX and
C.
CY, correct? CX and CY. CX. And here we have CY. What else?
The 2000 Newton.
2000 exactly in the middle, yes. Going down. 1000 Newton. What else?
And AB force from
FAB, right?
Yeah, FAB.
Okay. Yeah. Okay. You want to make it as tension or compression?
Compression. Tension.
Compression. Tension, compression. Well, then compression.
Tension.
Oh, no. I want it to be compression. If it's compression,
Okay.
the direction, and this is the line of action, right? It's supposed to be the line of action. It's supposed to be like this, right?
Yeah.
Okay. If it's compression, the direction is supposed to be to the top right or bottom left.
Top
Right.
right.
Yes, correct. Why you seems like uncertain about it? You're supposed to be certain, okay? You are doing it correctly. Top right. It's compression. FAB, like this, right?
Yes.
Okay. What other dimension that we have to know?
The 2 meters.
Yes,
Yeah, the
correct.
distance.
Yeah. It's 2 meters. Here is 2 meters as well. How about the angle for FAB?
60 degrees.
60 degrees. Here is 60 degrees, right?
Yes.
Good. Then now, The one in question is determine the horizontal and vertical components of the force here. So Cx and Cy. That's the one in question. Okay, Cx and Cy. Okay, that's the one in question. How can I find a Cx and Cy? But before that, how many unknowns that we have in this particular free-body diagram?
3.
3. What is that? What are those?
FAB, CX, and CY.
Cx, Cy. FEB, Cx, Cy. This is our unknowns. Okay. Now, how many equations that we have here?
Also 3.
3. What are those?
Sigma moment equals to 0. Sigma
What
fx
else?
equals to 0. Sigma fy equals to 0.
Okay. We have 3 unknowns and 3 equations. Can we solve for this?
Yes.
Okay. But now I want you to try to solve it until the end.
Okay.
Okay. So which equation that you want to use first?
Sigma moments equal to 0. Sigma moment
Against which point?
at C.
At C. Okay. Sigma moment at C equal to 0. Sigma moment at C equal to 0. Then we say, okay. Sigma moment at C equal to 0. What we have there? You want counterclockwise or clockwise positive?
Counterclockwise positive.
Counterclockwise positive, so like this. Then what we have there?
So we have the 2000 newtons
Multiplied
by 2 meters.
2 meters. What else? Positive or negative?
Positive.
Positive, correct. Yeah. What else?
And negative.
Negative.
FAB.
FAB.
Sin.
Yeah. Negative FAB.
Multiplied by sin 60.
Sin, right? Sin.
Yeah.
Sin 60 degrees. Multiplied by
4
meters.
meters.
Equals to
0.
Equals to 0. Now, from here, you can get FAB, right?
Yes.
What is the value of FAB?
4,000 divided by
4. 1,000. 1,000 divided by sin 60 degrees. What is the value?
1,154.0.
60 sin 60 degrees is
50.
everywhere.
Oh.
1,000 divided by sin 60 degrees, right?
Yes.
So what's the value? 1,000.
1,154.
1,107 in 60 degrees. Okay. Yeah. 1,000 divided by 1,000 just now what? 1,100.
154.0. 0.7.
0.7 Newton.
7.
So that's FAB, right? Now,
yeah.
How about CY and CX? Which one do you want to solve for, CX or CY?
CY.
CY, then using which equation?
Sigma Fy equals to 0.
Sigma Fy equal to 0. Then what we have here, you want going right positive or going left positive?
Going up positive.
Oh, sorry, going up or going down positive? Going up positive. So here is going up positive. Then what we have there?
Cy
Why?
minus 2000.
2000 Newton. Then
Plus FAB
plus
sin
FAB
60.
sin 60 degrees equal to 0, right?
Right.
Okay. FAB we have the value, so FAB sin 60 degrees we have the value. FAB sin 60 degrees is supposed to be around 1000. This one is supposed to be 1000. Then CY here, what is the value for CY?
1000.
1000. 1000 minutes, yeah, right. 1000 Newton. That's CY. Okay. Now, how about CX then? What equation that we have?
Sigma Fx equal to 0.
Okay. You want going right or going left positive?
Going right positive.
Going right positive. Then what we have there?
FAB cos 60 degree.
What else?
And Cx
Plus or minus?
plus
Plus Cx equal to 0. Then Cx equal to FAB, minus FAB cos 60 degrees, right? What is the value there?
577. 577.35.
Yes, correct. And that's 77.35. Right. Okay. Thank you, Adila. Let us check. Okay, 577.35 and 1000 CY. Okay. Okay, CY is correct. 1000 CX is 577. So, yep, you're doing it correctly. Okay, thank you, Adila. Okay.
Yes, sir.
So those are the simpler problem for this frame. Okay, frame piece. Okay, this is several other problem that we can try to practice on. Okay, there are a lot of much more complicated problem. For example, it's like this, then like this as well. Okay, like this, like this. Okay, these are the more complicated problem. Maybe for this one, I will put it as your homework for next week. Okay, so next week we can try to discuss about this. Okay, and or maybe we can discuss about this tomorrow as well. So let me decide whether it become your homework or not after tomorrow. Okay, we can discuss about this tomorrow as well. The more difficult one. For today, I will concentrate on the easier problem. Okay, I want to concentrate on the easier problem. This is another case which is quite easy. But for now, I will want to ask for Johan.
Yes, sir.
Johan, can you help me with this?
Yeah.
Okay. Can you determine whether we have two force member here or not?
I think CB.
Hmm?
CB.
PC, yeah, CB, PC.
Yeah.
Same. PC is two force member. Correct. Then the one in question is we have to find the horizontal and vertical components of the reaction at A and the force at C as well. So here, the reaction force at A we have to find, the reaction force at C we have to find as well. Okay. Can you help me to draw the free body diagram to solve this?
Yes. Sir.
Which free body diagram are you supposed to use? Which member are we supposed to draw?
BC.
PC. PC. Why we have to draw PC? Because PC is the first member. We have to isolate it as external force.
Oh,
PC.
yeah.
So which member are we supposed to draw?
It must be, I think, AD.
Yes, correct. Must be AD. Must be AD.
Yeah.
Okay. But before we can solve for AD, we have to solve for the pulley first. This particular pulley. What force is happening there? Okay. If I draw the free body diagram of the pulley like this, okay. Can you help me the forces happening there?
50 G.
50 kilogram force. I think I will use international unit. Okay? And I assume that G is 10 in order to make it easier. So 500 Newton here. If we have 500 Newton there, how about the other tension group? What we supposed to put here? Sorry, there's supposed to be another tension here, right?
Yes, sir.
Okay. What else there besides the tension there?
From the AD.
No. Yeah, from AD, yes.
Yeah.
At point D, what will be happening there? It's supposed to be dy and dx, right?
Yes, sir.
Because there is a pin. Dy and dx. Okay. Using sigma moment at point D, okay, using sigma moment at point B equal to 0, what we will have is P equal to 500 Newton. Correct, right?
Yes, sir.
Okay. Then after that, using sigma Fy equal to 0, what we will have will be dy equal to what?
500 Newton.
500 Newton. And using sigma Fx equal to 0, what we will have is dx equal to what?
500 also.
500 as well. But the calculation here, you have to do it properly, okay? But this one, because it's quite simple, I just do it straightforward. Now, let's draw for the member AD. This is member AD. Okay, what forces that we have there?
AX, AY.
AX, AY, correct?
DX, DY.
Dx, dy. Now, yeah, dx, dy, we have to draw the correct direction because this one we have the correct direction there. So here, at this particular point, at point D here, at member AD, where is the direction of dx and dy?
I think DX to the left and DY.
Why dx to the left?
Because
action and reaction.
Yeah, action, reaction, yeah.
Okay, dx here, we have the value there, 500 Newton. And then dy going to the up or down?
Down.
Down. Action and reaction. dy. What is the value of dy?
500 Newton.
500 Newton. What else do we have there?
BC, the force from BC.
BC. This is point B. Where's the direction of BC? You want it to be compression or tension?
Tension.
Tension. If it's tension, then the line of action is like this way, because that's the line of action of BC, correct, right?
Yeah.
And if it's tension, the direction is supposed to be to the left or to the right?
You're right. To the left. I'm sorry.
To the left, correct. It's tension. FBC. Now I'm asking you, Johan, how many unknowns that we have here?
3.
3. Which are, sorry?
AX, AY,
AY,
and FBC.
FBC. FBC. And how many equations that we have here? 3. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Correct, right?
Yeah. Mm-hmm.
Okay. The number of equations are 3. The number of unknowns are 3 as well, correct, right?
Yes, sir.
Can we solve for this one?
Yes. Okay.
We can solve for this. Okay, we can solve for this. We can solve for this as well. Because it is practice time for you as well. I think I want you to finish this as well. Okay, in order to find the one in question is okay. In order to find these 3, what we're supposed to do? Yeah. Which one that you want to solve first?
Sigma moment at A.
Sigma moment at A. Okay, good. Sigma moment at A equal to 0. Then what we will have there?
FBC times
FBC, yes.
times 0.6
Times 0.6
plus dx times 0.9
plus what? dx. No, you have to put it as 500.
Oh, okay.
Multiply by
0.9
0.9.
minus 500.
Okay, minus 500 multiplied by
1.2 meters.
1.2 equal to 0. Okay, what you have for FBC then? Hello?
FBC 250.
Sorry?
250 Newton.
250 Newton. Okay, so 500, 450, sorry, 600 minus 450. Okay, 600 minus 450, 600, right? 600 minus 450, 150 multiplied by divided by 0.6. Okay, correct. 250 Newton. FPC is line fixing. And what else?
We can solve for AX using sigma fx equals
Okay.
to 0.
Sigma fx equal to 0. Okay, sigma fx equal to 0, then we can solve for AX. What is the equation there?
AX minus 250 minus 500.
Minus 500 equal to 0. Then what we have is AX equal to
750.
this one, right?
Yeah.
Then using sigma fy equal to 0. What you have is
AY minus 500 equals to
AY
minus 500.
minus 500. What else?
Equals to 0.
Equal to 0. Then what you have is AY equal to 500.
Yeah.
That's all. Right?
Yes, sir.
Okay. Thank you very much. I think it's okay. It's good. You can help me to solve for this. Thank you very much. Okay.
You're welcome, sir.
I think for the rest of this, we can try to continue it tomorrow. Okay. For this particular problem, some other problem which is more challenging, I think I will just give it tomorrow. For example, like this and this as well. Okay. So that's actually the first part of frame and machine. Okay, most of the part that I have discussed until now is a frame. Okay, we haven't discussed a problem example on the machine yet, but the way to solve it is more or less the same. The way to solve it is more or less the same. Like this is a machine, okay, but I haven't discussed it yet. But this, so tomorrow I will try to discuss about this. Okay, and this one as well, I will try to discuss it tomorrow. Okay, so for the first 1 hour, I will try to give several examples on the machine, like this and this. These two I will discuss it tomorrow morning from 7 to 8. Then from 8 to 9, it's more to the Q&A session for our exam, for our midterm exam. Okay, I think it's supposed to be clear, right? Of what we will do tomorrow. Okay, any question about the frame animation, guys? About all the problems that we have discussed up until now, and all the definition as well. Hello, anyone? Anyone having any question? Sunita, is it clear, Sunita? Hello? Hello, Sunita. Where is Sunita?
Yes, sir.
Yep. Is it clear, Sunita?
Sorry, sir.
Is it clear? The explanation that I give to you guys today. Do you have any questions?
No, sir.
Okay. Good. And what else? Isabella, you ready? Do you have any question, Isabella?
Tidak ada, Pak.
Okay. Darian Patrick, you have any question?
At the moment, no, sir.
Okay. So most likely for you is still quite simple because the most problem that we discussed today is still very simple. But starting from tomorrow, I think I will discuss more complex problem, like the one in the machine, some of the machine problem that we have here. This one is quite complex, right? And this one as well will be quite complex. So these two, I believe, I will discuss it tomorrow morning. Okay. So then after that, I will give you some more homework. Okay, for next week. Okay, and try to study hard for your exam tomorrow. Okay, if you still have any question about the topics for the exam from the which is from the beginning until class, you can ask me from 8 to 9 tomorrow. So I will give I will put a special special section there, just for Q&A for the exam. Okay. I think that's all. See you guys tomorrow morning at 7. Okay. See you guys tomorrow. Okay. Thank you for listening.
Thank you, sir.
Yes, sir.
Okay, thank you very much, sir.
Thank you,
Thank you, sir.
Yes, sir.
Thank you, sir.